part of what we do in my practice is I gather samples of endometriosis and I gather genetics of patients and profiles and stuff, and I feed them that information, and then they turn on it and come up with exciting new pieces of knowledge. And what's really interesting about all this is that the clinical side of endometriosis right now is that it's either treated medically with hormones, which work okay for some people, but for a lot of people don't work very well, or surgically, which is what I predominantly do, which is pretty complex surgery that is very hard to scale, because it took me probably a decade of really devoting myself to the technicalities of endometriosis surgery before I felt like I was really good at it. And that's very hard to scale across thousands of surgeons that would be required if we were going to treat everybody with endometriosis that way. And what's really kind of fascinating about genetics research is that rather than figuring out one little, how can we do this procedure better, it's more like how can we understand the fundamental disease state better, such that we have a really amplified way of understanding how we might treat the disease. Because endometriosis, this is one of the things that I said in the last talk that everyone was kind of fascinated by, that part of grew into this talk, which is that diseases, things like endometriosis, when one person just has infertility and doesn't have pain, one person has no symptoms at all, one person has horrible pain and they have a little bit of endometriosis, one person has horrific endometriosis and they have bad pain before they may not have pain. Like, it presents so differently that usually when a disease presents that way, it's because it's not just one disease. And that endometriosis is probably not a single disease. It is a constellation of disease states that we call endometriosis, in the same way that we call cancer cancer, but I think everybody's quite familiar that not all cancer is the same thing. And yet, pretty much people monolithically call endometriosis one thing when it almost certainly isn't. It's actually related to cancer. We'll talk about there's genetic similarities in certain kinds of endometriosis and certain kinds of cancer. And by differentiating different kinds of endometriosis into what genetic subtypes there may be, in the future we will be able to know who's going to respond well to surgery, who's not, who's going to respond well to hormones, who's not, who might even have a very specific genetic mutation that maybe we can, in sort of the science fiction, maybe we, not really science fiction, but the future speak, and we can infect them with a virus that replaces the DNA that's screwing them up, and we can make them better. We're doing that already with certain kinds of very, very specific genetic mutations. For example, almost 20 years ago, or more than 20 years ago, there's a type of leukemia called chronic myelogenous leukemia. It's a very small subtype of leukemia, but they all have a very, very specific mutation. And it turns out that if you go and you turn off that gene in their body, they don't have leukemia anymore. It's very, very effective. That was developed at OHSU actually by a guy named Brian Drucker. And so the holy grail is to find a similar sort of way to look at endometriosis. The problem is that a disease like that is very specific. There's one specific mutation. Endometriosis has, as Ken will talk about, a tremendous number of mutations that seem to be associated with the disease. But the more that we know about it, the more we can get away from the simple answer of let's just treat it with hormones or let's just cut it out. Because what we know is that no one therapy works good for everybody. Some people respond beautifully to surgery, some people respond well to hormones, some people don't seem to respond well to anything. And the more we can understand why people have endometriosis, the more we can treat it better. And so Ken's going to talk about what we know about the genetics of endometriosis, and obviously we have a heterogeneous disease, we have a heterogeneous population here, and genetics can be talked about at a variety of levels, below, at, and way over people's heads. And so let us know if it is where we are, so Ken can kind of quantify that. And then we'll have as much time of question and answers as people would like, and you can ask me clinical questions, you can ask Ken genetics questions. Dr. Karen Miller is the medical director for Juneau Biosciences as well, and she may contribute. And then Libby Hopton, where's Libby?
She's networking outside.
Okay, so Libby Hopton, some of you may know, she runs the Endometriosis Facebook group. And so she is, because we have a relationship with Juneau, we have some funding, and we have Libby as our research coordinator for my practice. And so Libby actually lives in Portland, me, and so we're fortunate that Libby actually is able to work for my practice and kind of work with us in Juneau and doing all the genetics research that we do. So it's really fortunate that Libby's been able to get on board with that. So she's here as well, and if you have questions for her, I'm sure she'll be able to answer some stuff as well. So I'm gonna let Ken talk, and then you can answer questions, and then we'll give a tour of the lab and show you all the fancy ways to do this stuff. Okay?
Let me add my welcome. Thank you for coming, taking some time on your Saturday. I apologize, the lab's a little bit of a mess. I feel like I'm inviting you into my home right when the kitchen is being remodeled. But all of these walls are scheduled to be torn down, and that's why the temporary wall is up. And that's actually why we have this space, because the whole lab has been crammed into the front half because we're getting ready to make this space more efficient. This is a working medical laboratory. We are testing people for a variety of different things, and we're also discovering new disease genes. And many of you who are here from Utah may realize that Utah has been important in genetic discovery, but you may not realize how important it's been. I mean, Utah is known for snow and the great snow and Red Rock and lots of beautiful things and great people in the center of the LDS faith, etc. But it's also ground zero for genetics, especially human genetics. Genetics is only about 120 years old. DNA is only about 60 years old. But many of the key events have happened out here. The Human Genome Project started in Alta, Utah, at a meeting where a bunch of people got together and said, I do this, you do this, you do this. I wonder if we could apply any of this to humans. Because they all were working with yeasts and molds and fruit flies and stuff. And the opportunity was to do something in human research. And that's really where the Human Genome Project got started. And I was one of the early people in the Human Genome Project, even though I was a practicing OBGYN at the top of my field. I actually think I was a pretty good doctor in my day. But I felt a little bit like a fraud because we weren't advancing the science enough. We were doing a lot of things the same way they were done to my mother. I was born along, 60 years or something. But some of the things that we treat in women's health are the same way as when I was born. And that's like not true in anything else. No other field of medicine is like that. Cardiology is not like that. Pediatrics is not like that. Cancer care is not like that. So why in the world are there some of these women's conditions that we just haven't made enough advances in? So since 2007, I've been trying to do that full time. And because I came to being a geneticist late, my trick in genetics, the thing I do the best, is I don't start out with some cockamamie theory about what's going on. I let the patients tell me what's bothering you. And that's, I listen to symptoms very carefully. I don't think anybody's crazy. Whatever you're experiencing, you're experiencing. We correlate your medical records, your symptoms, everything else to your DNA. And DNA is a really simple thing. It's a chemical that all of our genes are made out of, that is the instruction manual for our body. So everything we can blame on our parents, I know there's some parents here, but everything we can blame on our parents is in our DNA. Now they didn't have any choices to which genes you got. And you may say my brother and sister are completely different than me. That can happen because we all get half of our parents' genes, and it's random which half we get. So sometimes siblings can be almost identical genetically, and sometimes siblings can be completely opposite genetically, just randomly by which half they got. So I hope all of you carry some of your DNA around in your pocket because it's the most important thing you can have. Here's my DNA. I had to give a whole tube of blood to get this much of my DNA out. So I'm going to pass this around. Don't open it. It's not that I'm hazardous, but it makes a mess. The reason that DNA is out of solution is there's some alcohol and some salt in there, so there's nothing that's harmful in there. But you can make DNA come out of solution by adding some alcohol and salt. When I teach this to like junior high school kids, I take all kinds of chemicals from the kitchen and I actually extract some of my DNA right there for them as a demonstration in class. And the way you get DNA is you just destroy everything else. Because DNA is like the solid diamond substance that cannot be destroyed in biology. Everything else is a wimp compared to DNA. So when we extract DNA, we boil it, we freeze it, we put acid in it, we put base in it, we do all kinds of nasty things that destroy proteins and destroy fats and destroy carbohydrates like sugars and things like that. And what you're left with at the bottom of the tube is a little bit of DNA. But boy, there's a lot of information in that DNA. So what you're seeing there, that white junk in there that has been described by my kids as kind of snotty looking stuff, that stuff is millions of strands of DNA, because each DNA strand you could not see. It's as 1/10,000 as thick as a human hair. And we all have a yard of it inside every single one of our 100 trillion cells. So we started out as one copy of that. And now we're 100 trillion copies of that. And we got that one copy half from mom and half from dad. But one letter wrong in that code can be the difference between life and death. There's 6.8 billion letters in the code. And one letter can be the difference between life and death. One letter can be the difference between tall and short. Several letters can be the difference between fat and skinny. And so we're trying to figure out those kinds of things. Now, when we got to endometriosis, we knew it was genetic because my patients told me a lot of their mothers and sisters and so forth had endometriosis. We never knew if their fathers had endometriosis. But we started this project by just taking a few women who had been operated on at the University of Utah. This is a genetic genealogy or genetic pedigree, and all of the women are circles in this diagram, and all of them, if they're filled in black, have endometriosis. And this is part of one of the first families we found out here in Utah that had endometriosis running in their family. And notice it's transmitted by both men and women. But when men carry the endometriosis gene, we don't recognize it because they don't have a womb and they don't have periods and they don't, but they probably have a condition. If you really start to look at the ones who carry the endometriosis gene, because we know about some men that have to carry endometriosis genes. So what this showed us is that all these women, many of whom thought they were completely unrelated, some of whom were black, some of whom were Irish, some of whom were Scandinavian, some of whom were British, some of whom were Italian Americans, some of whom were Mexican Americans, they all have this guy here as an ancestor in, should have brought my reading glasses, 1690. He's from Suffolk, Massachusetts in 1690. His family kind of came over with the Mayflower. We've actually traced him back further than that. We estimate there are 2 million people living in the United States who are descendants of this family line. That's an estimate. Half of them are women. And if they got this guy's endometriosis gene, they are more likely to have endometriosis today. So the way genes work, it's kind of like being dealt some cards in a card game. There's no such thing as a bad card. Depends on what game you're playing, right? But if you're playing the endometriosis game, I don't want to have it or I do want to have it, then certain cards contribute to developing endometriosis. And what we have found is that the average woman with endometriosis has 3 or more of these endometriosis cards, like the one I just described that came from England in the Renaissance times, when Shakespeare was alive. That particular family line is one of the genes we've discovered. We have now discovered 550 such lines that any one of you might happen to carry because of your ancestors. Not your fault. I happen to know that I carry one of them. which is fortunate for my daughters that I don't carry more of them. Because if I carried more of them, they might have endometriosis. You can get endometriosis even if you have none of these cards, but it's pretty hard. You have to really work at it. You have to have a lot of things going bad. But if you have 7 of these cards, your chances of having enough things going on to give you endometriosis starts to get pretty high. And then it's only like maybe one other thing has to happen. And it may even be like one other thing that happens to all women. So for instance, most women have a menstrual period. And almost always, just like blood comes out, some goes back inside. So that happens in all women who have menstrual periods. But some women who have that menstrual period going backwards, it actually stays and will start growing. And so what promotes that? Well, it could be a genetic change in the lining, or it could be a genetic change in the actual tissue that's in the lining of the womb that went backwards with the menstrual cycle. So it could either be where it landed, or it could be what landed. It could have a genetic change that's one of these cards. So we're used to thinking of these kinds of ideas like in heart disease. Like if you smoke a cigarette, doesn't mean you're going to have a heart attack, right? But if you smoke 3 packs a day for 20 years, and if you also eat really bad food, lots of fat, if you also have a genetic predisposition to have high cholesterol, if you also have high blood fats, you know, you start adding up enough of these things, and if your father and mother both died in their 30s of heart attacks, guess what? You're at pretty high risk of heart disease if I've just described you or your family. The problem in endometriosis is most of the things have been invisible. We can't point and say, oh, this thing in the diet will contribute. There are probably some things that are in the diet that affect, but they're really hard to understand. These things in the environment, we don't know about things in the environment. We suspect that dioxins are important, for instance, which can affect estrogen levels. And there's a dioxin Superfund site over by the Oprah Mountains. So we do know that endometriosis is more common in the neighborhoods around that area of town. So again, it's not all genes, but the genes and the protein and the foods and the exercise and the things in the environment, toxins and stuff like that, they're all working through our body's chemistry. And it's the genes that set up that chemistry. Does that make sense? So you can get the same effect by taking a medication perhaps, or taking a poison perhaps, or by eating the wrong things perhaps. But if you're born with 6 or 7 of these strikes against you, you don't have to do any of those things wrong, and you can still develop endometriosis through just normal activities of living. So what we love to do in our work, because it teaches us so much, is we like to compare people who have endometriosis, that we're sure have endometriosis, to all the rest of us, and say what's different. And the way we found those 550 genetic events in endometriosis is by doing exactly that. So it wasn't me coming up with, sitting up all night in the library trying to figure out this stuff. It was volunteers contributing a DNA sample, which is usually just some saliva from inside the mouth. If you did the Ancestry.com test ever, that's similar to what we do. By the way, we developed the Ancestry.com test here in our lab. And we did the first 60,000 tests, and it just got too big for us to keep doing that for them. But we developed it, at least the accurate part. It's been some inaccurate parts. And we developed it because we had so many samples. And we work with large numbers of samples at a time. And everything is in miniature in the DNA world because we get so little DNA out of your sample, but we can use it for years and years and years to do this kind of research. Partly because we figured out how the body copies DNA, and we can actually Xerox your DNA and make more copies of it in short little pieces to study. And so also, we use miniaturization. Like for instance, these are today's test tubes. I'll pass this around too. This is 384 test tubes. They aren't like the ones you had in high school, but are much smaller, so it's much less expensive to fill these with expensive chemicals that we use for sorting out your DNA. And we can test a lot of people at once. So we've collected about 30,000 samples that are relevant to our endometriosis research. Sometimes we make even smaller test tubes. That's 384 at a time. We actually can go to 1,084 at a time on one plate this size. Everything is handled by robots, so we don't make mistakes. Everything is bar-coded, so we never mix up a sample. Everything is done in miniature, so we can save costs, and yet it's still very expensive to do this kind of research. Right now, we're funded by a private company that is trying to develop new tests for endometriosis, and that investment was really hard to get because a lot of people didn't care enough about women's health, but we pushed and we pushed and we pushed, and we eventually got some serious investment. In the last 10 years, the federal government probably spent about $3 million a year on endometriosis related research, which is nothing compared to the $80 billion or so that endometriosis costs in healthcare expenses. If you have endometriosis, your healthcare costs are about 60% more than your neighbor who doesn't have endometriosis. And by the way, that's before you were diagnosed and after you're diagnosed. So you've had more symptoms, you've had more things that are bothering you. Probably you've gone to a lot of doctors who don't understand what's going on, who told you just buck up, or you're just being a woman, or they sent you to the wrong kind of specialist or whatever. In the United States, it usually takes 10 to 12 years to get correctly diagnosed as having endometriosis. And the average woman has been to 4 or 5 specialists that know nothing about endometriosis, that may have put you through other kinds of testing and so forth because they're worried it was a bowel disease or a neurologic disease or this or that or the other. So again, we monitor all that, we collect all that information, but then we don't listen to all the theories and we don't listen to all the specialists. We have your DNA tell us what's going on. Now, this is one of the chips we use for testing, and would be an example of an early thing that we do when we get the samples. Is this particular chip is a silicon wafer, just like the kind of wafer I would have in my phone. But instead of putting an electrical circuit so that I can text my daughter, it has DNA on it that's been manufactured in place the same way this chip puts circuits and capacitors and resistors, all that kind of stuff that I don't necessarily understand. But the same factory that makes these chips can make these chips. And instead of spraying it with electricity, oh, I just took a selfie. Instead of spraying it with electricity conducting stuff and all those circuits, we spray it with the building blocks of DNA. So on this little silicon wafer, there's 6.4 million pieces of DNA, each designed to answer a question. And we squirt your DNA in one side and we squirt some developing chemicals in the other, and we can make this chip glow, fluoresce, 3 different colors at each one of those 6.4 million dots. And it will tell us yes, no, or maybe for each of those genetic questions. So we start with that. I'll pass this around also. This is $250. Single use, so only one person can be tested on that. And we'll walk around and we'll show some of the machines that we do all this with.
Is that one used already?
That one's been used. So when I started in this, 1986, we used to have to make all our tools in the garage because there were no genetic tools. When I graduated from medical school, there was only one human gene that had been sequenced. So all of this has happened in my professional career. When I was born, there was only 2 facts about human genetics that were known in 1957. One was that we have 48 chromosomes, the other is that our gender is determined whether we're boy or girl is the same way in fruit flies. Both of those are wrong. So everything about human genetics has been learned in my lifetime, most of it just recent. The first human woman was only sequenced in 2008. Now, by the way, we had done mice and flies and yeast and the bacteria that causes urinary tract infections and a bunch of other things first. I actually was testifying before Congress and saying, don't you think it's a tragedy we haven't sequenced human women yet? And we're doing all these other things? And they really didn't have much of an answer. But cows had been sequenced before human beings, human women had been sequenced. Human men were sequenced 8 or 10 years earlier, $900 million, 60 different centers involved in doing the first human sequence. And it was a breakthrough. It was important. It happened during the Clinton administration. It was a very important thing scientifically. It opened up the future. Now we sequence people on a chip, another chip. Those are the electrical connections that read out the sequencer. And these are the places where we're squirting the DNA. And it's actually reading off the electrical charges on the DNA as it's producing copies of your DNA. And this is $450 each. This has also been used, so you're not ruining anything. But we do make a significant investment in everyone who participates in our study to add something to human knowledge. I've described you just some of the raw material costs, but we usually spend tens of thousands of dollars per patient to learn what we can learn next. And compared to all the government funding that has been used in endometriosis, we're spending about 2 to 3 times that much right here in this room, which we raised from private investors, which was like pulling teeth. So in this lab, as we walk around, there's about $12 million worth of equipment. And it's all right now being devoted to women's health research. We also study preeclampsia, preterm birth, birth defects, a variety of other conditions that impact infertility, etc. And then we also test women. We don't just come up with an answer and just leave it there in the science books. We then launch tests that can help doctors and patients understand better the heterogeneity, the differences in the different flavors of this disease. We hope to accelerate that even further. We're supposed to be getting a pretty big investment in the next couple weeks. We've got a lot more international interest in our work now, and so hopefully this is going to move faster and faster. But it still depends on the very basic of people who have had endometriosis or think they have endometriosis, just kind of sharing their story, being willing to share their medical records, and being willing to share a DNA sample. Everything is kept extremely confidential, higher level of security than medical records normally are kept. And we separate the DNA sample from the record very quickly by giving it just a code number and barcoding and other things so that nobody knows anybody's results. By law, we can't share any of the results with participants until it's a medically accepted fact. And then once it's a medically accepted fact that everybody agrees on in the medical community, then we can offer testing back to you. And what we've been doing is doing it at no charge for people who were involved in the studies. So we are delivering answers to people. Some of Dr. Fogelson's patients, when they come to see him, they're getting a risk score right now that helps determine how likely it is that somebody has endometriosis. In the infertility clinics around the nation, we're starting to offer a score that tries to help which people with infertility are more likely to have endometriosis and how should that change their approach toward having a baby. Let's see, I think my DNA lab in my pocket, I think I've probably gone through all the things I'm carrying around in my pocket. But I do want to show you around the lab. And I'd love to have you participate if you're interested. There's no obligation, but if you are interested, it helps advance the science. That's the only way the science is advanced. I can promise you we will protect your information and treat it like it's gold, because it is. 30,000 other women have participated. We'd love to have even more participation from Utah, because Utah has a larger family size. They know more about their genealogies in general, et cetera. So samples from Utah have turned out to be particularly valuable in this hunt for endometriosis gene. I only ask, if you don't want to participate, please talk to 5 of your friends who have endometriosis. Ask them to participate, because no, I mean that's how a revolution in this particular disease will occur, because the scientists aren't funded well enough. The doctors can't figure it out just by taking care of patients and doing the same thing that they've always done. It requires the few scientists in the world that are really interested in this. It requires us having access to stories and validated records and things like that. So when Dr. Foguson complimented him and says, I'm like the leading scientist in the world about endometriosis research, it's a pretty small race. You know, there's only a few of us. But I think it is true that we're way ahead of those other few, and we've had the luxury of being able to spend more money doing this. And that just means more patients have told us their story, and we've been able to correlate them with the DNA, and then the DNA tells us its story, its ancestry, and how it all developed. So I said a lot. We're going to get up and stretch our legs a little bit, but let's answer some questions first about genetics.
Would you say it's accurate to say that if they want to be in the study, it just requires they've had surgery? It doesn't matter whether they did or didn't have endometriosis? They can be in the study either way.
For this particular study, that's who we advance, but we're actually willing to collect samples from anyone who's interested, including people who don't have the disease at all and know they don't have this disease. Actually, that actually proves to be a very valuable group. If you've had surgery and we're 100% sure they didn't see any endometriosis, which is difficult to be 100% sure. Because if you've had a laparoscopy to look for endometriosis and they didn't find it, well, doing a laparoscopy is kind of like crawling around a tennis court on your knees looking through a little tube like this. And it's very hard to look at every inch of the tennis court surface. Really good docs who are committed to it, like Dr. Foguson, they do that kind of work. And that's why his surgeries can take, hours to make sure he's found everything. And if the patient is asking, please get rid of everything I have right now, he'll be very thorough about doing that. But when I look at a medical report that says we didn't see any endometriosis, and I look that they were only in the operating room for 10 minutes, then I know, because we know.
Yeah, there's how many holes do you have in your belly? It is impossible to look for endometriosis with a camera alone, or a camera and one other instrument. I mean, I use at least 3 and usually 4 puncture sites to do endometriosis surveying. So you got to move everything around. You got your assistant hold something out of the way, and so when I see people come to me and say, I had endometriosis surgery, they didn't see anything, so they only have 1 hole in their belly or 2. I'm like, well, they didn't look. It's impossible. And no matter what they told you, it is impossible to thoroughly survey the pelvis or the abdomen through 2 puncture sites.
So we want to move away from this being a surgical diagnosis, because we actually think that genetics is more relevant than what you see. So this surgery diagnosis, remember I told you things didn't change much in my lifetime. This surgery diagnosed endometriosis 160 years old.
Older than that. Think your stuff going back into like Galen Greek times.
But the first time it was proven under a microscope. The first time it was proven under a microscope was 160 years ago, and that's how we've been defining it ever since. Can you think of anything that's diagnosed the same way as 160 years ago? I mean, like strep throat? No. Heart attack? No. Cancer? No.
Prostate exam?
Right. Prostate exam is still pretty primitive, but they have ultrasound, they have a lot of other things. But it's yeah, it's time for a change, right? And instead of just saying it's there, we got to be able to say, well, this is what it means. You have an invasive form. You have a form where there's a cancer risk, unfortunately. You have a form where you might have infertility. You have a form where surgery is likely to make it better. You have a form where surgery is likely to make it worse because of the wound healing from the surgery might actually be what the problem is that's causing the endometriosis to begin with. You have a form that might respond to hormones. You have a form that won't respond to hormones, so don't even take them and suffer from all the side effects from them, right? But wouldn't that be nice if we could just say that at the beginning? My dream is actually, we'll screen 12-year-olds for this tendency. And if you have it, we would suppress it then, and then never deal with it. When my daughter was 12, we had the technology, and I must admit we tested her. And fortunately, she didn't have any of these bad endometriosis cards. But if she did, with what I know right now, I probably would have recommended that she be on a very low dose of progesterone until she's ready to start her family. And we might have, if it was a progesterone responsive endometriosis, which most are, we might have prevented the disease from ever developing, even though she had 7 bad cards. So that's the future, is, you know, you got something that 1 in 10 women have. There's got to be a way to prevent it from impacting their lives. You know, it's okay to say, okay, maybe I have this tendency, but if it never affects you, isn't that what we want, right? We don't want it to affect you. And some people, it affects quite severely. And I'm not here to tell you horror stories about how bad it can be. Fortunately, for most people, it is a manageable condition. But wouldn't it be nice if it wasn't there at all because it was a prevented condition? And that's where medicine always tries to move to. And through these genetic studies, we may end up having the knowledge to prevent this, because at its basis, it's chemical. And these chemicals now we know how to manipulate, sometimes through very simple things. I'm not talking about gene therapy or changing your genes or something. I'm talking about sometimes it could just be adding a small nutrient to your diet. Even an herb to your diet might be enough to change the way your chemistry works. I'm not trying to sell herbs or anything. I'm just saying that there is an herb that is well studied now in endometriosis that actually does have a positive genetic basis for why it might work. They got to prove that it does. But if you're going to prove that it does, you should only give it to the people that have that flavor of endometriosis, that have that card. If you try to give it to everybody, guess what? You might not be able to prove it works. So it's all about targeting or personalizing medicine. The drug industry has a horrible record in this. Do you know that on average, prescription medications taken correctly are the third leading cause of death in the United States if it were a disease? And do you know that prescriptions that we write as physicians, 30% of the time, it does exactly what it's supposed to do. 30% of the time our patients won't take it, probably because of side effects and other things. 30% of the time it does nothing, but the patient keeps taking it, which is good for the pharmaceutical company, but is not helping the patient. And 10% of the time the drug actively is hurting the patient. Could you imagine if Delta Airlines had that kind of industry track record? 30% of the time you get on the plane, you go where you're supposed to go. 30% of the time you get on the plane, you just sit at the gate. And after 4 hours, they let you out. You're still there in Salt Lake City. 10% of the time the plane crashes and burns.
The time you end up in Provo.
And then 30% of the time they don't let you on for whatever reason. You can't afford the ticket or whatever. I mean, imagine if another industry had that record. And that's what the prescription drug industry has as a record right now. What we're trying to do is say, don't give that drug to 100% of people. Only give it to the third that you know they have the chemistry, they have the cards where it's going to work in them.
From a clinical perspective, one of the things I think is so important about this, because I know a lot of you communicate online, and some of you may read a lot of different stuff about endometriosis online, and I think that what is promoted online about endometriosis is very important, but I think it's also very simplified. I think that one of the things that's being kind of elucidated by Ken here is that it's very complicated. Disease is not all one thing, and any one answer that is promoted as being the answer to everything is wrong. And I'm an endometriosis surgeon. I love doing endometriosis surgery, and I do it well, but I am acutely aware that what I do is not the answer for everybody, and that some people will benefit dramatically, and some people won't. And when people don't benefit from surgery, it doesn't mean the surgery was done badly and then you go find another surgeon. Because I think that's a message that sometimes is promoted online. The reality is that there are people that have no idea how to operate on endometriosis, and if they try, they don't do it very well. I mean, the goal of endometriosis surgery is to thoroughly remove all endometriotic tissue from the pelvis. That's like removing cancer. It's very difficult to do. Sometimes it's like someone has thrown paint in a room and they say, okay, remove all the paint from the walls. Leave the walls intact and make sure the roof doesn't come down. And it can be impossible. And so there is definitely poorly done surgery, but even perfectly done surgery doesn't always work, or it may work partially. And I tell my patients, if I make you 50% better, I'm kind of satisfied, and if I make you 75% better, I feel like I've succeeded. And if I make you 100% better, then we're really lucky. But I would never tell anybody that thoroughly removing endometriosis is going to make them 100% better. And I say that, you know, it's pretty likely that I can make you 50% better, and maybe I'll make you 75% better. And so, and if I only make you 50% better, the answer isn't to have another surgery to get the other 50%. It'll probably make you worse. And so sometimes I see a story online of that the person that didn't do well with surgery because the surgery wasn't done well enough, let's find another surgeon, or a more expensive surgeon, or, you know, and so it's so much more complicated than that. And I would love to get the day where what I do is pointless, like there's no point operating. Because even if surgery were the answer, it's utterly unscalable. It took me a long time to get good at what I do. It takes me years. I spent 2 years with minimally invasive surgery fellows teaching them who have already qualified as OB/GYN surgeons. Spent another 2 years teaching them how to do endometriosis surgery. And at that point, they're just sort of like barely ready to start teaching themselves to get better. And it's going to take them another 5 years to be really good at it if they really want to commit themselves to doing it, which many do not. And so even if surgery is the only answer, it's utterly unscalable. And so this kind of stuff is way more scalable, which is why we need to, in a lot of ways, focus on the underlying reasons for why people have disease rather than the Band-Aid fix.
I'll tell you just a couple other facts that we've seen. In Utah, people on average are 22nd degree relatives. So if you pick any two people off the street, there's 22 steps between you and that other person on average.
Where's Kevin Bacon?
If you're a person in Utah with endometriosis, on average it's only 8 steps to the other person with endometriosis. So you're not endo sisters necessarily, but you're endo cousins. You actually are fairly closely related to each other in this group if you have endometriosis, because you only got the endometriosis because you had to share some of these cards, and not all ancestral lines have those cards. So that's one thing. If you have a mother who was clearly diagnosed as having endometriosis, your chances of having endometriosis in Utah is 5 to 8 times higher. If you have a sister, it's about 6 to 7 times higher. The sister's been surgically diagnosed, definitely has it. So we know this runs in families. And I've run into families in Utah where they say, don't go to Dr. So-and-so, he's not any good, because in our family newsletter, there's 40 women who've had endometriosis surgery this year, and the ones that go to Dr. So-and-so are getting good results, the ones that, it's amazing how you don't have to teach Utahns a lot of times about genetics, because if you have a larger number of sisters, a larger number of cousins, a larger number of aunts, and so forth, the genetic patterns sometimes become more obvious to you. And remember, don't take the men off the hook. They pass on endometriosis genes just as well. Sometimes the family history is nobody on my mom's side has endometriosis at all, but my dad's side is chock full of endometriosis. Well, guess what? He probably had some endometriosis genes that were passed on to you if you have endometriosis. And again, none of them were necessarily enough. You had to have some other triggers that occur. But depending on how many of those cards you have, we can score whether you're likely to get endometriosis or not. But what we're hoping to score is what type endometriosis we get, how will we best take care of it, etc. So let me just answer any questions about genetics right now. Dr. Fulgenson can answer other questions about treatment and about clinical factors. But anything else you're interested in about genetics? Yes, sir.
Not necessarily about genetics, but are there any specific politicians that are pushing for more funding?
Warren.
Warren?
Yes.
Elizabeth. Oh, and
Orrin Hatch
oh,
was.
Warren. I think it's the Warren.
Elizabeth
Warren,
Yeah, her and
Orrin Hatch was, and he actually serves on the board of directors
Oh,
of our company,
so-
believe it or not. The first board he joined after leaving the Senate. He is very influential because he knows a lot of people who run pharmaceutical companies, medical research organizations, etc. Because he was always on the health committee in the Senate and served for a long time. He also has a granddaughter with absolutely severe daughter-in-law. And it makes a difference. People who have personal experience, it does make a difference. There are quite a few Hollywood movie stars who have talked about endometriosis and their story, and they've made a difference. I think the more people who have kind of come out publicly in high-profile situations, it's actually been very good for starting to create some awareness.
You guys, anybody watch Dancing with the Stars? So what's the blonde girl's name?
Julianne Hough.
So when Julianne Hough was a dancer, and they said she's missing this week because she had done emergency surgery, and then she came back, and she said, I've been having abdominal pain, I had to have an appendectomy. I was like, she's got endometriosis. and sure enough, now she's like this endometriosis spokesperson. Because I remember she was talking about how she'd been having pain for years and years and years. I'm like, well, that's not appendicitis.
Yeah.
She said, I had an appendectomy. I'm like, no, you had endometriosis surgery. That was interesting. So she's kind of come out with it.
Yeah, she has
Lena-
4 cousins in one branch of her family who have severe endometriosis as well.
Lena Dunham as well. And one of the things that really pisses me off is that Lena Dunham's out there talking about endometriosis, and rather than saying, go Lena, thanks for raising awareness, people are angry that she's not saying the right thing. And I mean, I don't think within like the endometriosis advocacy community, there's people that are angry that she took Lupron, or there's people that are angry that she's had a hysterectomy. It's like, it's all bullshit. It's like, there's different ways to treat different people. Lupron is not a great drug by any means, but it does benefit some people. Some people have terrible side effects with it. But if her experience was that she felt better on it, that was her experience. And the disease is extremely heterogeneous. Some people, that drug got on the market not for no reason. It does have efficacy in endometriosis. The problem is that it has tremendous side effects and all kinds of very expensive. But so Lena Dunham said a lot of things that like some people in the really hardcore endometriosis advocacy community were angry about. She had,
I missed the point.
yeah, they missed the point. Is that awareness is awareness, and that's what really matters. And the disease is very complicated. And again, any one monolithic idea that anyone says is absolutely true is wrong. It's too complicated to be correct for any one thought process to apply to all people, because it just doesn't.
It's probably time to stretch our legs. We'll just take a brief tour around the other rooms and show you some of the equipment that we use and how those little tools work.